All right, so we're going to solve some quadratic relationships using the quadratic formula. Now, in the past, you've dealt with completing the square, which can, let's be honest, be a total pain in the butt. Well, I'm here to tell you that using the quadratic formula is far easier. But let's take a look at how it's derived. So if you take a look at a standard quadratic relationship, you can then use completing the square to come up with the quadratic formula, which is right here. So then, you don't have to remember how you get it. All you have to remember is the actual formula. Now the actual formula is, and I'm sorry for my poor singing, it is negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, what's up with all of these a's and b's and all that type of stuff? Well, you'll have to remember, or you will remember, that a quadratic relationship is typically written ax squared plus bx plus c is equal to 0, where a is the coefficient for the quadratic term, b is the coefficient for the linear term, and c is the coefficient, well, it's just the constant. So let's take a look at this. So we have to be able to figure out what your a, b, and c values are. So what is your a value in question 1? Well, your a value in question 1 is 6. What is your value for the b? What is your b value? Well, it's negative 10. What is your c value? It is 4. So let's go ahead and plug this in. So what is our b? Well, we have negative, our b is negative 10, plus or minus the square root of, what's our b value? Negative 10 minus 4a and c. And then it's all over 2a, so we have 2 times our a value, which is 6. So now we are going to go through and we are going to just compute this problem. So subtracting negative 10 is the same as 10 plus or minus the square root of, what is negative 10 squared? Well, negative 10 squared is 100 minus, so we have negative 4 times 6 times 4, so that would be a negative 96. And this is all over 12. So what is 100 minus 96? Well, it's 4, so we get 10 plus or minus the square root of 4 over 12. Well, what is the square root of 4? Well, the square root of 4 is 2, which is really helpful. So really, we end up with 10 plus or minus 2 all over 12. Now at this point, I have to tell you, it's not always going to work out that nicely that you have a whole number here, and that's okay. But at this point, you need to go to positive land and negative world. Now our positive land, we have 10 plus 2 over 12. In negative world, the land, we have 10 minus 2 over 12. 10 plus 2 is 12 over 12. Well, 12 over 12 is 1. 10 minus 2 is 8 over 12. Well, that equals 2 over 3. So there we have our two answers, and that's it. Let's take one more example that's going to be a little bit more difficult. Waiting for it to erase. Okay, there we go. So now we have a quadratic, and we're going to remember that we're looking for a squared, or ax squared plus bx plus c is equal to 0. Now, on question 2, do we have this problem in that form? And the answer is no. It's not equal to 0. We need to get it equal to 0. So here we go. So we have 4y squared plus 8y minus 27 is equal to 0. And now it's time to recall the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So now let's identify all of the a, b's, and c's. So our a value is equal to 4. Our b value is equal to 8. And our c value is equal to negative 27. So now let's plug these in to the formula. So we have negative, our b value is 8, plus or minus the square root of 8 squared minus 4 times 4, that's our a, times our c value. And that's all over 2 times our a value, which is 4. So now let's multiply what we can multiply. So our negative 8 doesn't change, so we still have negative 8 plus or minus the square root of 64 well, it may not be minus, so we have a 1 minus, we have a second subtraction. So the negative times the negative is a positive, so this will be positive. And 4 times 27 is 432, I believe. 432. So then, that's all over 8. So let's add what's in the square root bracket. So we have negative 8 plus or minus the square root of 496, and that's over 8. So now the square root of 496, that's not a perfect square, but I'm pretty sure square 16 goes into that, times 31. So let's just double check so you don't have to take my word for it. So 496 divided by 16. Hey, look at that, it worked. So the square root of 16 is 4 times the square root of 31. So I'm going to rewrite this in that form. So we have negative 8 plus or minus 4 root 31, and that's over 8. Now, wait a second. All three of those terms share a factor. 4 goes into 8, 4, and 8, doesn't it? So what we can do is we can say, I'm just going to reduce. 8 divided by 4 is 2, 4 divided by 4 is 1, 8 divided by 4 is 2. So really, we have negative 2 plus or minus the square root of 31 over 2. So now, it's time for us to go into positive and negative world. But before we do that, I want to point out that this here, that is the answer in simplest radical form. So in positive world, we are going to have that negative 2 plus the square root of 31 over 2. In negative world, I'm going to reduce this piece here, if it lets me. It's freaking out. Alright, well, we're just going to erase it then. Alright, so then in negative world, we have negative 2 minus the square root of 31 over 2. And so the square root of 31, I think is like 5.67. Let's see. So 31 square root 5.56, 5.57, I'm sorry. So we have negative 2 plus 5.57, rounding to the nearest hundredth, divided by 2. Over here we have negative 2 minus 5.57. So then subtract 2 and divide by 2. So over here we get 1.78. On the other one, we have 531 square root. And we'll divide that by 2. And so we have negative 3.78. So we have two forms of the answer. We have the simplest radical form, and we have the decimal equivalence here. That's how you use the quadratic formula. Hope this was helpful.